Welcome to another episode of Agentic AI, the future of intelligent systems. Today, let me ask you something unusual. Do you know that every time an AI agent thinks, reasons, or takes action, water may be involved somewhere in the system powering it? Real water, not virtual resources, not abstract infrastructure, actual physical systems helping keep intelligent machines running. Now, at first, this sounds confusing because when most people think about AI, they think about intelligence, powerful models, electricity, maybe even rising energy consumption. But water? That part of the story is almost invisible. As agentic AI becomes more capable, more autonomous, and increasingly woven into everyday life, water may quietly become one of the hidden resources behind intelligence. Now, to be clear, AI systems are not literally drinking water. Nobody pours water into a chatbot. Nothing about the experience feels physical. You type something, an answer appears, an agent completes a task, life moves on, everything feels digital, invisible, instant, almost effortless. So, where exactly does water enter the picture? The answer begins with something surprisingly simple: heat. Computers generate heat. Powerful computers generate even more heat. And modern AI, especially systems powering agentic AI, they require enormous amounts of computation. Behind every intelligent interaction sits infrastructure, massive data centers, thousands of servers running continuously, processing requests from millions, sometimes billions of people. And those machines get hot, very hot, hot enough that cooling becomes essential because overheating slows systems down, damages hardware, creates instability. So, data centers must constantly remove heat, and in many cases, water becomes part of that story. Some facilities use water based cooling systems, some rely more heavily on air cooling, some increasingly use reclaimed or recycled water instead of potable water. And sometimes the story becomes indirect because the electricity powering AI can also depend on water during generation, which means even if water never touches the servers themselves, it may still be part of the wider infrastructure supporting intelligence. And suddenly, something surprising happens. What felt entirely digital starts becoming deeply physical. Every intelligent interaction now has an invisible layer beneath it: infrastructure, energy, cooling, and quietly, water. Now, here's where the story becomes even more interesting. Because agentic AI may change the equation, not because agents are bad, not because intelligence should stop evolving, but because agents behave differently from traditional software. Traditional software waits, you click, it responds, and then it stops. But agents reason, plan, retry, search, coordinate tools, work across systems, sometimes continuously, sometimes invisibly, sometimes without us fully realizing how much activity is happening underneath. And as these systems become more useful, we will naturally use more of them. More intelligent assistants, more automation, more always on systems quietly working in the background, helping us organize, research, monitor, write, decide, and perhaps even act on our behalf. One interaction may feel small, one extra reasoning step may feel insignificant, one additional retry may not seem like much. But scale changes everything. Millions of users, billions of interactions, persistent intelligent systems running every day, quietly, continuously, and suddenly small things stop being small. But here's where the conversation becomes even more important because water is not equally available everywhere. A liter of water consumed in one place does not always carry the same consequence somewhere else. Some regions have relatively abundant water resources, others already face increasing pressure. Droughts, heat waves, groundwater depletion, agricultural demand, growing populations, and rising competition for fresh water. In many parts of the world, water scarcity is no longer a future concern. It is already happening. And this raises an important question. The issue is not simply how much water is associated with AI, but also where is that water impact happening? Because the same intelligent workload running in different locations may carry very different real world consequences. A data center operating in a water rich region may create one kind of impact. The same infrastructure running in an already water stressed area, that becomes a very different conversation. And increasingly, where infrastructure gets built may become shaped not only by electricity availability but also by water constraints. And perhaps this is where agentic AI introduces a new responsibility, not fear, not resistance to innovation, but awareness. Because intelligence is quietly becoming infrastructure, and infrastructure choices matter. How agents are designed matters. How much unnecessary computation happens matters. Where systems run matters. How intelligently we use intelligence may matter more than we realize. Because perhaps the future challenge is not building AI that simply thinks more, but building AI that thinks responsibly. Systems that understand when deeper reasoning is valuable and when simplicity is enough. Systems that avoid waste, waste of computation, waste of energy, and yes, sometimes waste of water. Because maybe the future of intelligent systems will not simply be defined by capability or speed or autonomy, but by something much harder: efficiency with responsibility, the ability to build systems that are powerful while remaining thoughtful about the invisible resources quietly supporting them. Because every intelligent interaction feels digital, but somewhere beneath the surface, servers are running, heat is being generated, cooling systems are operating, resources are being consumed, and sometimes water is quietly involved in keeping intelligence alive, a resource so fundamental to life that we rarely stop to think about it until scarcity forces the conversation. And perhaps that is the bigger lesson here. The future of agentic AI is not only about making machines smarter, it may also be about becoming smarter in how we build the machines around us. Until next time, keep rethinking what intelligent systems should be.